So my experience in the automotive related engineering field comes from my work at GM in the transmission design. So in this role, I am creating, maintaining, and updating drawings for and models for our transmissions. And with the current environment now, this is also spreading over to the our electric drive units as well. So I experience in mainly the structural components, the cases and housings of these transmissions and electric drive units, and as well as in the internal components, specifically the gears and shafts, as well as the seals connecting the structural components together, as well as internal seals for internal lubrication. The items that I picked up in skill set from GM include tolerance stack up analysis, as well as knowledge of GD&T and how to properly apply them to the parts. I also have a unique experience in PMI and learning how to incorporate a model-based definition into the workflow, which I think is still growing. It's still a new process and technology that is slowly working its way into the automotive field, as well as other component design engineering fields. So again, my experiences at GM are specific to the automatic transmission as well as electric drive units. So designing components for structures and internal gears and shafts for the products across the GM portfolio. For the transmission design team, I am working on the drawings and 3D models for these components as they go through the engineering change process and working across functions as well, since we have to interface with the electrical sub team with the new electric programs that are coming into our workflow. So with my skill sets in GD&T knowledge and tolerance analysis, specifically to these automatic transmissions and electric powertrains, I believe is a strong skill set that is should be very useful for this position at Workhorse. So my experience in data calculations have come from some of the projects I've had to complete at GM. Specifically, I'd like to highlight my design for Six Sigma project, where I had to look at the performance gains that are possible if we move from traditional methods to model-based definition type of workflow, and using PMI to feed our tolerances into a 3D analysis software. So in this project, I had to learn how to run a two-sided t-test and collect the data to analyze and compare the performance between old process to this new process. From Raytheon, I in that design role, I've had to utilize my knowledge from college in terms of statics and stress calculations, as well as fundamentals from mechanical design and mechanics of materials as well. So I'm comfortable working with hand calculations to calculate stress for simple designs. If the geometry gets more complex, I have used FEA tools. Specifically at Raytheon, I have used the SolidWorks FEA tool to validate my designs. So one of the challenging issues that I encountered at my time at GM involved issue I found with one of the structured designs for our electric drive unit. There was an issue with the geometry, the electrical enclosure cover that mounts to the case. The geometry did not match the seal profile, the shape of the seal gasket, and I had to investigate what the issue was. So I reached out across our functions to the electrical sub team, and we were able to meet with the supplier to find out what the issue was. It turned out that they have not received an updated uh, version of the geometry for the case in a few months. So they were not aware of the design changes. So I work closely with this supplier engineer to get them a copy of the geometry and send it to them so they could revise their design and uh, feed us back an updated version of the cover that works with the geometry. So again, to reiterate, my experience with suppliers, as from one of the answers on my questions with the case, is an example. On top of that, I've also worked with our bearing suppliers to make sure that the models they send, as well as their drawings, are in line with our internal standards. So I would meet with them to make sure they understand our requirements, as well as try to keep updated with the status updates from their end, and make sure that they also are getting the correct information from us in terms of what our package requirements are. Those are my experiences with working with automotive suppliers. I believe the strongest skill set I offer for workhorse in the powertrain engineering role is my knowledge in GD&T as well as tolerance stack-up analysis. Um, in addition to my skill set in design and handling 3D models and drawings. Um, and combined with my experience at Raytheon, working for a small in a small team of engineers in a fast-paced environment, I believe these two experiences combined give me a strong skill set to do well at Workhorse. So again, 3D tolerance analysis, design in terms of updating drawings and handling 3D models in both Siemens NX as well as SolidWorks, along with being comfortable in working in a fast-paced environment in a small team where I am have to be responsible for a lot of roles, not just design, but as well as testing and analysis. So in terms of CAD software, I'm competent in both Siemens NX as well as SolidWorks. Um, and I'm comfortable with both PDM systems. So that's Teamcenter for NX and SolidWorks PDM for SolidWorks. On top of that, I have experience with some 3D tolerance analysis software. So specifically, I've worked with Sigmetric CETOL as well as Dassault Systems or 3DCS. Their package called 3DCS made by DCS. That those are the packages that I'm have experience using. So I'm very comfortable with being hands-on. I actually think that's the most fun part of a job, if I'm able. I am very comfortable working in that kind of an environment from Raytheon. I can't tell you exactly what I've done at Raytheon, but it's very hands-on work, and I'm very comfortable getting my hands on the products I design. It gives me an extra, a different perspective, and I think it's for me highly valuable to be able to work hands on with the products that I design. I'm always open to learning new tools if needed. I have some enjoyment in picking up new things, especially if I get hands-on experience with that. I'm always open to weekend work where needed. At the end of the day, if I need to solve a problem, I'm usually very focused on getting that done. So wherever it's needed, I know the importance of taking time outside of work to typical work hours to solve a problem. So again, weekend work is open for me.